and welcome to another episode of Interactive Control, the place to get all your burning industrial control questions answered. I'm your host, Michelle Rosinski. Today my guest is Craig Resnick, Vice President of the ARC Advisory Group. Craig is the primary analyst for many of ARC's automation and financial services clients. His coverage includes digitalization, industrial IoT, I 4.0, enterprise integration, industry best practices, and operational excellence. His focus areas include digital transformation, automation platforms, edge, OT/IT convergence, production management, and HMI SCADA software solutions. Craig's prior experience includes sales, marketing, product development, and project management in the industrial market, gained with major suppliers of PLCs, process control systems, power transmission equipment, and field devices. Craig holds a BS in electrical engineering and an MBA from Northeastern University. Today, Craig is going to talk to us about how data analytics and other recent technology trends are impacting industrial control applications. Let's listen in on our discussion. Hi, Craig. Thanks for being on the show today.
Thanks so much, Michelle, for having me.
Yeah, it's so great to have someone from ARC on our episode today. So I guess I want to start out by asking if you could talk a little bit about your role and your past experience and how that's led to your knowledge of our topic of data analytics in industrial control applications.
Okay, well, thanks again, Michelle, for having me. I've been with the ARC Advisory Group for about 21 years, so an awful long time. I typically cover the automation space, so I certainly deal with a lot of the major suppliers of automation systems. I also work with many of ARC's customers that utilize these automation systems, and also work with the financial community as well that are interested in some of the market trends of the automation system providers. So working with those companies, you can imagine we're spending a lot of time questioning about their solutions on data analytics, industrial control applications. From a background perspective, I started way back in the 1980s in the process control world, and then I with a major supplier of process control systems that we all know. And I moved in the 90s. I was with a major supplier of PLCs that I think we're also very, very familiar with as well. So having product management roles and project management roles. So I've certainly spent a lot of time in plants, and actually in my role with ARC, I'm certainly also visiting quite a few facilities that are using process control systems, DCS systems, and certainly applying data analytics to a lot of those applications.
Wow, yeah, that's quite a list of experience. And so we're very lucky to have you giving us some of your time to talk about this today with all of that background. So just to jump in here, can you give an explanation of maybe what the different kinds of data analytics, and there's so many different ways that we can define or talk about data analytics. So to kind of set the tone, how would you define data analytics and maybe some of the different types of analytics that you've seen being used in conjunction with industrial control applications?
Okay. I think at ARC, we probably look at it as to three different buckets, shall we say. The first one might be the area of performance, which is really when you're saying to yourself in a process, what is happening, what has happened, and why. So think about it. You're doing chemical processing. You've done the appropriate batching and mixing and blending or refining, and now you're saying you're looking at the end product and you're trying to figure out did it come out as specified or not, and if it did, great, and if not, why did it not? So many cases we get involved with analytics that are looking at those parameters and making sure that the process has been run appropriately, and if it hasn't, what needs to be done going forward to make sure that the future batches run correctly. So that involves a lot of descriptive and diagnostic tools. It does a lot of focus on things like current and past performance. And you certainly part of performance analytics involves data discovery tools. If you want to move a little forward and then you say what's kind of the next level, the next bucket we would call would be is predictive analytics. That's really a matter of what's likely to happen. It could be based on structured or unstructured data. Sometimes you're applying things like big data, data scientists, machine learning, and business rules, and may involve different toolkits. And when you're thinking about predictive analytics, you might be doing, let's say you're doing an application, let's say like the corrosion management, where you want to be able to predict, is there going to be any sort of a corrosion issue in any of the in pipelines? And what you're doing is you're basing it on past experience. You're basing it on a combination of the analytics is looking at the age of the equipment. It's looking at what chemicals or what have you are being run in that process. Historically, what has happened, when corrosion has happened, based on timelines or based on the amount of process hours. So a lot of that has happened. So you're actually gets you to the point where you're now able to predict when you're going to be having corrosion problems, and now be able to make the necessary decisions, maybe when you're going to have a planned shutdown or a maintenance shutdown, or when you can go ahead and make the necessary repairs so you're not involved with an unscheduled downtime, which obviously is the biggest sin, as you certainly know, in any manufacturing application, is you want to avoid unscheduled downtime at all costs. So that's predictive. Now what you do is the next level of analytics would be on the prescriptive side, which is kind of, what to do, which is obviously based on a lot of the same knowledge base that predictive analytics is based on. And except what it does is it adds in some different options and implications that you would plan towards, because it really helps to further optimize a lot of the automation of the decision-making process. And, an example of that might be, let's say, for example, you were going through, let's pick a refining as an application, or a cat cracker, where what you're doing is not only are you trying to plan what you anticipate is going to happen, but let's say, for example, you detect that there's a problem in a particular cat cracker, and you need to be able to now reschedule your refining process. What you may do is you may divert product to another cat cracker, for example. You may change the production schedule as a result. You may, if for example, there's an equipment problem or a problem with an asset that's causing an issue with a cat cracker, you may be in a situation where you can schedule the maintenance to come in. So not only are you now predicting what's going to happen in the future, but you're now able to make feed-forward decisions regarding manufacturing, so you can now divert product or divert production schedule around that problem. So if you look at the three buckets of performance, predictive, and prescriptive, one is kind of analyzing what happened. That's performance and optimizing that process. Predictive enables you to be able to figure out, based on prior history, what's going to happen, and certainly be able to plan for a problem when it does, before it occurs, and avoid unscheduled downtime. And prescriptive allows you to try to take the best of predictive, but enable you to make the best business decision going forward. Again, how you can best meet your production schedule and how to redeploy your manufacturing assets to achieve that goal.
So could you talk a little bit about COVID obviously has impacted so many things, including industrial control and how the different, processes perform, supply chains, so many different ways. Could you talk a bit about how COVID has maybe impacted data analytics or other related technology trends with industrial control applications?
Well, I'll tell you, the one thing that COVID has done is it has greatly accelerated the whole digital transformation, process. I mean, companies that at one time were just contemplating, where do they begin their digital transformation journey, all of a sudden got a rough dose of reality when COVID hit, and really moved them to think in terms of, kind of new modes of operation. And, thanks to things like analytics and digitalization and emergence of, say, open process automation standards, IT/OT convergence, manufacturers were able to apply a lot of those technologies and move from, I would say an on-site model to a remote operations model. And what I mean by that is there's a time in most plants, whether it be due to control issues or security issues, that in many cases you could not monitor or make decisions outside of the control room, for example, in major process applications. And now when people were forced to work at home, or plants that were allowed to remain open but with strict social spacing policies, where you'd have to spread the workers out throughout the plant that were there, you no longer did you put a lot of people in the control room sitting in front of the console and get all the information at your disposal and be able to make all the right decisions. You were making those decisions either from home, or some companies were using remote knowledge centers, monitoring, multiple control rooms, or even, multiple plants. So you really had to totally reinvent the way that you were bringing that information to, say, the control room operators, and giving them the power that at one time they may not have had to be able to make control decisions from outside of the control room. So, it really, talk about a disruptive technology. I mean, it really upended the way a lot of companies do things. But you couldn't have the decision making, you couldn't have the ability to make those decisions remotely if you didn't have the appropriate data analytics that kind of brought out that additional dimension of information to you. So this really enabled, all the workers to kind of continue making these value-added, decisions and value-added tasks, improve reliability and, predictability of the plant, but be able to do that from whatever location they were capable of working in. And this has made a tremendous change. And what's real interesting here is, as we talk to companies, as we're beginning to kind of approach hopefully the end of the pandemic, and hopefully, say, by the fall, maybe a herd immunity. So we're talking to these companies and saying, are you planning on going back to the old way? And what we find is we're getting kind of a hybrid response, which is, well, there's certainly some processes we definitely want to do all the monitoring and control again within the plant. But we might have more of a hybrid model where maybe some of these applications can be done from remote locations or from remote knowledge centers. So it's really interesting how COVID will have a lasting after effect on these processes, and has really accelerated both the digital transformation of these processes, and certainly the whole area of the use of data analytics, as an additional knowledge management tool to monitor and control these processes.
Yes, acceleration, I think, is one of the key impacts that COVID has had around data analytics and some of these other, technology trends that you mentioned. So along those lines, right, I think there is this potential move to having more autonomous operations in the future, sooner rather than later, especially with this acceleration. So do you have any advice for operators, engineers, maintenance personnel that might be looking to prepare for the future with these new technologies, especially, the impact of autonomous operations?
Yeah, it's a great question. At ARC, we spend quite a bit of time, writing about, blogging about new technologies, creating white papers, doing podcasts such as these. And I would really suggest that anybody that is certainly working in process plants or manufacturing plants, that some of the things they focus on is certainly they want to learn all about analytics. And just as we talked today about the 3 categories of analytics, it's certainly something that they need to learn about. I think they need to learn about the role of artificial intelligence. And a lot of times when people will say, well, where do I even start? Well, most in certainly almost every process plant, you've been storing historian data, for many years. And it's really that data is going to be the foundation for artificial intelligence in the future, because essentially what a lot of these analytics packages do is they go into that historian database, and you got, often terabytes of data, and you're going through that, and based on all that history is how you're really doing a lot of the artificial intelligence and machine learning in the future, because it's really just a matter of what happened in the past and how do I make the best decision going forward, based on past scenarios. So certainly to learn about artificial intelligence and machine learning and analytics and looking at and using the historian as that foundation, because that's really what is going to help create the autonomous operations, of tomorrow. Is if you don't have that history, you really can't make these decisions going forward. And, a lot of times people get nervous and say, well, what's my role in the plant if for some reason these systems are making all the decisions for me, and then where is my role? And
Yes.
I'll tell you, in some cases, it's actually going to elevate the need for process engineers, because now they're going to be able to get, when these decisions are being made, you're going to have access to a much higher level of data and information. And what this is going to do is it's really going to give you far greater decision-making power overall, because now you are really going to be tasked with, how do I increase the productivity of my plant, the profitability of my plant, and certainly in a lot of hybrid applications, let's say in food and beverage and pharmaceutical, how am I going to increase the OEE, or overall equipment effectiveness of my plant? So instead of just making decisions based on looking at pressures and levels and temperatures and flows, you're going to be making decisions on a lot of the data that's come through the analytics. How can I optimize my production? How can I, catch a downtime before it occurs? How do I make sure my supply chain has a necessary real time and visibility that I can make fast supply chain decisions if for some reason I find that a portion of my supply chain is constrained because of geographic issues or geopolitical issues, or whatever may occur or climate issues that might take a plant out, unfortunately. So this is a case where the level of knowledge and decision making that's going to be required from the operators is going to increase, and all I could say is that your value will actually never be greater, because you're going to get to the point where you're making the decisions that, even through having the best analytic tools and having the best tools for artificial intelligence and machine learning and autonomous operations, but you still need the human factor, because you're going to have a much higher level of information presented to you, and that's going to require you to make decisions that are going to have a far greater effect on both the top line and the bottom line for your company, and really raise your value as an employee higher than it's ever been.
Yeah, I'm so glad you brought up that point of, the potential concern that's out there around data analytics and autonomous operations, and it, affecting the job security of the people that are running the plants today. And, I think you make such a good point that those jobs aren't going away, and really the scope of what's expected of those roles is actually going to increase, right? You'll have to be aware of the different types of data analytics, not at the algorithm level of how they're calculated, but understanding the outputs, understanding where, the limits of what data analytics can and can't do, where there, may be something you want to go double check, and then what to do about the information that you're getting because of the data analytics. So, and I love your point too, that ARC is a great resource. I myself have read several articles and white papers from ARC, and it has helped me quite a bit to stay up with the trends. So that is a great suggestion for anybody that's, thinking about the future and what their job might look like, how they can prepare for that. We're talking a lot about data analytics, but another big trend right now, and I think with COVID, there's been some acceleration with this as well, is around augmented reality and virtual reality. So could you talk a bit about what you at ARC have seen happening with those technologies in the industrial control space as well?
That's a great question, because if you look at ARC's market research, and we write quite a bit of studies, so we're always doing how fast the market is growing and growth rates, and looking at 5-year CAGRs. Probably some of the fastest growing technologies in the space are augmented reality and to maybe a little lesser extent virtual reality. What augmented reality does is it kind of connects, virtual design to the physical equipment for operations and maintenance. It's used in wearables in the plant. It supplements HMI solutions from remote work locations. It's really like adding a third dimension to HMI. I mean, a lot of times when people will use it sometimes in some applications on their from their phone, for example, and they may use it for some fun applications where you're actually putting a template over looking at a picture of reality. And so think of this in the plant. Now you're looking at a process, and now you're getting all this additional information supplemented over the picture of reality. So you're kind of doing a mixture of what's actually there and supplementing information on top of that. So now all of a sudden you're at home and you're say staring at a tank within the plant, and not only are you getting the level of the tank, the temperature of the fluid in the tank, let's say, or the pressure of the fluid filling the tank, or flow rates of the fluid that you'd find on a normal HMI, but you're now able to get that at greater data that's supplemented as you're staring at the tank, because that information is now being applied so that you're visual. So it's almost like having your own three-dimensional HMI that gives you a perspective of data that's presented to you, so you can make the best possible decision. And for people who are in the plant and using, let's say, like a wearable device, or whether it be a Google Glass or a RealWear helmet, for example, you're now able to walk the factory floor, walk the plant floor, and have that information. Sometimes it's based on your GPS position within the plant. Sometimes it's based on staring at a QR code that's on the asset itself. But now all this information is being supplemented to your visualization. Now think about this from a maintenance person. So now all of a sudden, not only do they know what they're staring at, but they're also getting safety parameters, for example. They're knowing, for example, am I now in a hazardous location, either because of chemical exposure or because of high voltage, for example. So it may give me the instructions to how to avoid any sort of a safety issue, and if I do need to go into sort of a area where I need to cut power or go to an e-stop, or it'll give me those instructions. So think in terms of the fact that it's like having, like wherever you walk within the plant or whatever you're looking at home, you have a combination of the visual and the instruction manual all at your fingertips, and the necessary drawings and information, and in many cases, sometimes the step-by-step process it takes to make a decision. So to us, augmented reality might be the one of the greatest technology adds right now that we've seen, and from looking at the purchase orders that companies are spending on augmented reality solutions, it seems to fit the agreement. Virtual reality, a lot of people are very familiar with from gaming. And although you're not going to find too many Fortnite applications when you're walking the factory floor, but at the same time, if you're used to wearing, certainly a headset, and you're now immersed into a situation, and think of how well that does from an area of training or practicing a simulation like a fire or an explosion in a plant. You certainly don't want to have to simulate that in real life to practice how to respond to an explosion or a fire. But at the same time, it immerses you in that situation, and because it kind of connects, mechanical, electrical, control software. It helps like with validating and commissioning. I mean, think of all those factory acceptance tests that at one time you would have to fly to your process control supplier to go to the staging area to have to go through, and now you can sometimes do that through virtual reality. Because you're in that whole you're leveraging the immersive technologies, and when you think about if there's how to pilots for years have been trained is that they train in certainly flight simulators, and they practice engine flameouts and crash landings and making sure the scenarios that you certainly don't want to have to ever experience. But in those hopefully very infrequent times when there is a problem in the air, but it provides the pilot with the necessary training so they are prepared for any sort of response. So, virtual reality has really come into play as a training and simulation tool. And the thing that's interesting about it is as more millennials and Gen Zers are entering working in the manufacturing space, as a lot of the baby boomers are retiring, it actually becomes an attraction, that the fact that they can use some of the technologies that they're familiar with and that they actually enjoy on their spare time and can apply it in the real world. And for sometimes where where careers in manufacturing in the past may not have been as attractive because it's maybe a little bit less, you feel as though in the past you've been working on older technology and with longer product life cycles. This is a case that you're able to use some of the technology that you enjoy using in your day-to-day life and be able to apply that to the plant and factory floor.
Yeah, that's really cool. I bet for a lot of the newer workers, like you're saying, and helping them to come up to speed on things that they haven't had experience with directly yet, right? So, So yeah, the virtual reality is you're immersed, and it's good for training and simulation. And then the augmented reality is, you're still looking at the real world, but you have these overlays on top of it. And exactly. I can understand how your explanation of a worker in the field, with being able to see real-time values for the equipment that they're looking at overlaid, and have, that access to reference materials or step-by-step guides, how powerful that could be for any worker, but also, especially for newer workers as well. So very, very interesting stuff, and certainly, not going anywhere anytime soon. This is the direction that the industry is heading in more and more. So is there anything else that you think is important to discuss around technology trends right now in industrial control?
Oh, absolutely. I mean, if there's one phenomenon that's been going on for the last several years, is the whole area of convergence. It's really convergence between IT groups and OT, which I would say there's probably no processing plant, manufacturing facility that's not at least going through the beginnings of IT/OT convergence. Everybody's kind of at different maturity levels, but that also takes into account, converging the cybersecurity aspects of IT with the cybersecurity aspects of OT. And also the fact that sometimes even different domains, many times you have maybe a DCS for automation, then you have a DCS for power, for example. Some companies have, separate domains between the power and automation. We're even beginning to see that converge. So, as we look forward, there may be a time in the future where the gap between IT and OT, or the power and automation, for example, may all come together. Sometimes we even call it technology fusion, that at some point down the road, we may not be having to talk about convergence anymore, because in some companies, some of these groups may become one. And this is a little ways off, and there's some companies that are, again, at different points in that convergence journey, but that's something that that we're certainly looking to do down the road. All of a sudden, as a result of the pandemic, the whole term operational resilience came into play. And what that really meant is to make sure that you reduce any sort of supply chain vulnerability and lower safety risks and improve operational performance. Again, a lot of that pandemic driven, and making sure you're really optimizing, production throughout the plant life cycle, wherever the worker may be and whatever the situation of the supply chain is. The other thing we're seeing is, far greater use of edge computing platforms, at the site level, for gathering, analyzing, processing, and storing data in real time, and close to the point that data is being gathered. And in many cases, what we find is that it results in hybrid applications where you combine that real-time data stored at the edge, and then you're sharing a lot of that data with the cloud, which is more often than not data that's more for production management or things that are maybe not necessarily needed in real time. Your historian data is a great place to be in the cloud, but obviously if you need to gather data in the certainly in a millisecond rate or a second rate, as you would, let's say, in many process control or discrete control applications, you really need to have that data gathering at the site, have that data analyzed and running some of the analytics that we talked about earlier on site, and be able to make those decisions and feed it back into the control system in real time. So having greater use of edge computing is also going to be really, really growing.
Yes. So in summary, I think I heard you mention the IT-OT convergence and, how that also relates to cybersecurity. Also, operational resilience and edge computing.
Yes.
Did I miss anything in there?
No, I think that sums it up. I would say, in addition to a lot of the technologies that we talked about earlier, certainly regarding, analytics and artificial intelligence, machine learning, augmented reality, and virtual reality. I'd say that that's really a pretty good summary as far as, where things are going and the technologies that I think people are going to be working with and learning, and it's going to certainly have a greater effect on everybody's role going forward.
Great. Yeah, that's great information. So, last question. Before we go, can you talk a little bit about ARC, what it is and what its purpose and how it can help listeners?
Okay, well, thanks very much for that question. ARC's been around since 1986. It's a global technology research and advisory firm. We cover everything from industry and infrastructure, smart cities, smart buildings, and our clients are, kind of fall into three primary categories. It's certainly the people, like the Baker Hughes, that certainly are technology providers. We certainly have many clients that are on the user side of the business that are certainly in the oil and gas and chemical, pulp and paper, automotive, food and beverage, pharmaceutical, water, wastewater industry. So those would be many of ARC's user clients, as well as the OEMs that manufacture, machines. And then the third kind of client we have are as I said, the financial analysts that are researching and trending the industry, and in many cases making those buy, sell, and hold decisions on the stocks of those particular companies that are certainly participating in the manufacturing space, both from a supplier and user perspective. So we give those companies, we call them advisory services, which are, a year-long subscription to have analyst access and get a whole bunch of written deliverables sent their way, and then have multiple, we call forums, or essentially user groups, where we get groups of people to speak and present their technology that we locate throughout the world. Obviously, this year is virtual forums, but we hope to return to live forums in the future. We do things like technology evaluations, selection services for technology. We write a lot of market reports. How big is the DCS market? How fast is it growing? What's the outlook for that market? And we probably have about 100 of those reports based on a variety of different solutions and technologies in both hardware and software for industry, infrastructure, and smart cities. And there's a whole bunch of analysts like myself that certainly do a lot of consulting services and working with some of our great clients, such as Baker Hughes.
Thank you for that explanation. Tons of good information and resources available through ARC for our listeners. So, I do recommend check it out if you're not already. Thank you so much. This has been such a great session. I think, we've gone through all of the questions, but this has been really helpful information, and I think this will resonate with listeners. So can't thank you and ARC enough for your time here today.
Thank you so much, Michelle. Great to be here, and hope to have a future podcast with you.
Thanks. Me too. All right. Have a great day.
Thank you.
Thanks, everyone, for joining me for today's episode of Interactive Control, where we went over how data analytics and other recent technology trends are impacting industrial control applications. We at Nexus Controls hope you found this discussion helpful. If so, please subscribe to our podcast and tell all your control friends about us. You may also want to check out our website at nexuscontrols.com, where you can learn more about how we can help you with your data analytic needs. I would also encourage you to check out ARC's website and the resources available there. Lastly, don't forget the title of this podcast is Interactive Control for a reason. If you have a topic you'd like us to cover that we haven't yet, please send me a message over LinkedIn or email, and we'll do our best to cover it in a future episode. Thanks again, and bye for now.